Okay, we have a blue graph and we have a black graph. Which one is cosine? Do you remember?
Blue.
Yay, good. The blue one is cosine and the black one is sine. All right, let's kind of remember what everything is. What is, it doesn't really matter which one, cosine or sine. What is the period of this graph? Pi? 2 pi. Why is it 2 pi? Yeah, it repeats itself every 2 pi. Or you can see that the highest point here and the highest point here is different by 2 pi. So this is one period. Period is how long it takes for it to repeat itself. Okay, so I usually look at the highest point and the highest point, or the lowest point and the lowest point. I don't look at the middle because it gets very confusing. Amplitude.
2.
What?
It's
1.
One. From where?
from the x-axis to, or it's to like the middle.
Yeah, the middle to the top or middle to the bottom. Okay. So this is amplitude. So in this case, it is 1. Okay, so this is graphically. So looking at the graph, this is how you find out. Let's try to see how we can find it from an equation. Usually equations look like this. A, or some number, sine bx, or some number times x, plus c, and then there is a plus d on the outside. Which part is the amplitude? Yes. And it's absolute value a, because we only talk about the actual length and not whether it's negative or positive. All right, period is a little bit confusing. Period, there's a formula. Period is 2 pi over absolute value b. Okay, frequency, we didn't learn this last year. Frequency is 1 over period. So that is b over 2 pi. Next thing is phase shift. Phase shift means how much are you offset by the original graph. So that is c. If c is greater than 0, we're going to go to the left. If c is less than 0, we're going to go to the right. And then up and down has to do with d. So if d is greater than 0, we're going to go up. And then if d is less than 0, we're going to go down. Okay, amplitude. So we talked about this. Amplitude is the total overall height divided by 2 because we count it from the middle. So we take the total height and we divide by 2. All right, let's look at the following problems, and then we're going to also find the transformation from the parent function. A. What is the amplitude of A?
1 over 2.
1 over 2. So amplitude is 1/2. What's the transformation? Transformation from what parent function?
Cosine x.
Cosine x is the parent function. So that 1/2 does what to the graph? Compress which kind? Vertical or horizontal? Vertical. Vertical compress by 1/2. All right. Okay. Let's have you guys try B and C. So you just need to find the amplitude and the transformation. B. Let's try Gary. What is A? 3. Philip, give me one transformation.
Vertical. I don't know.
Stretch or compress?
Compress.
Compress, not compress. We always look at the absolute value of the number. So it's going to be 3, which is bigger than 1, so it's going to stretch. So vertical stretch 3. G, what's another one? Reflect x-axis. Okay. C is a little bit tricky because it is a cosine graph, but there are some things that's not, exactly correct. So we had to figure out the transformation. So C. Murphy, can you tell me the amplitude?
3.
Yes. So what you do is you take the overall height, which is 6, and then divide by 3. That's the amplitude.
2 divided by 2.
Oh, so yeah, divide by 2. Sorry, divide by 2. Elizabeth, what is one transformation?
Vertical. Oh yeah, vertical stretch 3. Sorry.
Vertical stretch 3, correct. And then Raymond, can you find the last one? This one's a little bit tricky. Up 1. Okay, so basically this graph should have started at 0 and then goes up 3, down 3. So this time it's going up to 4, and on the bottom it's going down to -2, so you know it moved up 1. All right, let's look at the graph. All right, let's not guess anymore. Okay, so we are going to write cosine as sine, as a movement of sine. So cosine is the same as sine moved which direction?
Right.
Left.
Okay, it might be faster if we move left, right?
Yeah.
If we take the black one and we move left, we can go on top of the blue one. How much do we have to move?
1.
1?
Pi over 2.
Pi over 2. Okay, if you move the top to the top, it's by pi over 2. Which direction?
Left.
To the left. So left by pi over 2, when you write the equation, you put plus pi over 2 or minus pi over 2?
Minus.
Why are we having so many answers?
Plus.
Plus
Why?
pi over 2. Why? When we go to the left, we always add, right?
One.
Oh no. Okay. All right. Review. Okay. All right. Let's look at.
So,
Go ahead.
so what's the function looks like?
The function. How should it look like? It's a cosine function, so it should start on the top and then goes down like that. And then we'll probably get to some graphing today. Yeah. All right. Next. Period. It means the length for one cycle of the wave. So for the graph to complete itself once, and we're trying to figure out how long that is. So what you usually do is you look from the maximum to maximum or minimum to minimum. Or from the equation, here's what you do. You look at B. So A is for amplitude, B is for period. Now, if you look at this equation here, what number is B? B is the number that's multiplied to X. 1/3. Okay, so then the period is 2 pi over absolute value B. Okay, so it's 2 pi over 1/3, which is 6 pi. So it takes 6 pi for it to repeat itself. Okay. All right, let's have you guys do B and C. All right, let's look at it. So let's do Lisa. Lisa, what is the period for B? Pi. And then Jingzi, what is the period for C? 2 pi. All right. We are now going to look at horizontal stretch or compress or shrink. Okay, this is where this number is underneath, which in this case, it is B, right? Oh, actually, it's not B. It's the number below. So, like if you have sine of x over 3, the 3 is the number we're looking for. So that is going to be stretch. So if this number is greater than 1, it's going to stretch. If this number is between 0 and 1, it's going to shrink. All right, frequency is the number of completed cycle or complete cycles within a certain interval. And it's easier if you just memorize the formula. So frequency is 1 over period. So that is absolute value B over 2 pi. All right, let's look at A together. What is B for A? 2/3. Oh, sorry. B is 2/3. So then we are trying to find frequency. So we take 2/3 divided by 2 pi. So that is 2/3 times 1 over 2 pi. So that is 1 over 3 pi. All right, let's do the hard part. What is the transformation? That 2/3 is going to be the problem. Everyone has the correct, but shrink or stretch. Okay.
Stretch.
All right, let's try to change it so it's correct. So it's going to be 4 sine x over 3 over 2, right? We're trying to make that number look like it's in the denominator. So that 2/3, just think you're going to flip it and then put it in the denominator. So it's 3 over 2. So number is 3 over 2. Are we stretching or compressing? Stretch. Okay, so it's going to be a horizontal stretch. Three over 2. And then what else? Vertical stretch. 4. All right. Okay. Let's have you do B. So find the frequency, find the transformation.
Negative?
All right, Bruno, let's have you do the first one. Frequency is what?
2 over 1 over pi.
1 over pi. Yes, 1 over pi. All right, Andy, give me one transformation.
Vertical stretch by 3.
You took the easy one. Vertical stretch 3. Okay, Raymond Yao.
Horizontal compress by half.
Okay, that is correct. So basically you want to change this so that the number is in the denominator. So this becomes sine of x over negative 1/2. Okay, Sunny, give me the last one. Yeah, reflect by y-axis. Yes.
How do I know the number of the compass?
You take this number whatever the number is, if it's not already in the denominator, if it's in the denominator already, like there's just like x over 3, then don't change it. If there's not a number in the denominator, you take the number next to it and you take a reciprocal. So if it's 2, becomes 1/2, put it in the denominator. If it's 2/3, becomes 3/2, and then put it in the denominator.
Does the order matter?
The order in this one doesn't matter because they're all multiplied. But if you have a phase shift, you have an up and down, then it matters.
Okay.
Yeah. Mm-hmm. Does the comparison shrink matter? To be honest, it doesn't because you're not changing the point. Like you're just stretching it, shrinking it, and then stretching it, shrinking it. So this point doesn't move, then it doesn't really matter. If this point moves, then the stretch and compress matters. Like the order will matter. Oh, sorry. Oh, you mean like the words? It doesn't matter. Okay, last part, phase shift. Phase shift is the horizontal translation of the graph, how much it moved. Okay, write the cosine function as a phase shift of the sine function, meaning you can see that the sine cosine are pretty much exactly the same, right? Except if you moved one, it would be on top of the other one. So this one says write cosine as a phase shift of sine. So basically cosine of x is equal to sine of x plus what? Oh. Okay, well, let's look at the graph.
B.
Oh my gosh. Okay, let's not guess and let's look at the graph. Okay, so this is sine graph plus pi over 2. Okay, if you take the sine graph, move it to the left pi over 2, it looks exactly like cosine. All right, next one, you can do the practice. Write the sine function as a phase shift of the cosine function. So sine is equal to cosine plus what? Or minus what? It doesn't, let's just put here, I don't know what it is. How do you move the cosine graph so it looks like sine graph? You might have to look at your graph because, yeah, I'm going to leave it there. So you're going to have to look at your sine and cosine graph. We move cosine so that it looks like sine. Yeah, minus pi over 2. Now remember that you don't have to just move this direction, right? You could also move the other direction, but your phase shift is different.
3 pi over 2.
Yeah, 3 pi over 2 because they add up to 2 pi. Okay, so there are more than one way to move. And then you can move even more, another 2 pi to line up on each other. All right? Okay.